Now we are moving towards the but last point of the chapter, that is the free, forced and resonance. Free and forced vibrations. Just we are going to remember or remind that definitions. What are that? Firstly, we are going to see what is the free vibrations. Free and forced vibrations. Obviously, the name suggests that free, that is free, and forced, it means that we are going to force that. Exactly similar to like that, free and forced vibration. The example is like that. Let's see. When we are going for study, and it is by default. That is, we are going to study by our own. That is the free vibrations. And instead of that, if someone is going to force to study you, it means that our mother or father or our teachers, if they are forcing you without your willpower, they are forcing you to do study, it means that there is a forced vibration. It means you are forced to study. Like that, these two vibrations, they are free and forced vibration, in which what happens in free vibrations, when a body capable of oscillating is displaced from its stable equilibrium and released, it makes oscillations which are called free oscillations or free vibrations, and the frequency is called natural frequency. Similarly, instead of that, the forced vibrations, the vibrations of body under the action of external periodic force, in which body vibrates with the frequency equal to the frequency of external periodic force and which is other than its natural frequency, it is called as forced vibration. And finally, we are going to know that what is the resonance. Resonance, it is the again a special type of forced vibrations. Forced vibrations in which this phenomena is going to follow like that. The phenomena in which the body vibrates under the action of external periodic force, whose frequency is equal to the natural frequency of driven body, so that amplitude becomes maximum. What happens in this case of resonance? Free vibrations and forced vibrations, and there is a resonance. A resonance is the special type of forced vibration. In case of resonance, let us see what happens. In case of resonance, the body vibrates with larger amplitude. It means that amplitude of vibration, it is going to be maximum. If we are going to apply the phenomenon of resonance in case of sound, it means that intensity of sound is going to increase. If the frequency of the body, that is natural frequency, and the external periodic force which is having the same frequency, then this is going to happen. That is what the body is going to vibrate with larger amplitudes. Now, what is the examples of this resonance? There are some examples which are given in our textbook. One of the example is that two oscillating pendulums, like that. There are two pendulums and they are connected by means. Now, what happens in this case? If you are going to oscillate this pendulum, and similarly, simultaneously, the second pendulum, it is going to oscillate. But when the resonance occurs, it means that these two pendulums, they are going to vibrate or oscillate with the same time period or with the same oscillation of frequency. The frequency of oscillation is going to remain the same in this condition. Therefore, this is the one of the type of or the example of resonance. Another type of resonance example is that when doctor uses the stethoscope, in which the stethoscope's diaphragm is going to vibrate with the frequency of the heartbeat, which is going to produce that vibrations, and therefore these vibrations, they can be heard in the ears of the doctor. That is the use of that resonance, one of the use. Another use is that we are going to use that resonance for applications. Different types of applications are given. These are the examples. What is the use of that resonance? Why we are going to use that resonance? What is the use? The use of resonance is that, firstly, let us see, if we are given a tuning fork and we don't know the frequency of that tuning fork, the frequency of tuning fork is unknown to us, and if we have another tuning fork which is of known frequency, and if we are going to vibrate these two tuning forks with the same frequency or the same vibrations, but it does not happen because the frequencies are different. And if the frequency of tuning fork is going to match with that of unknown frequency, then the resonance could be occur and the intensity of sound is maximum, and hence we are going to determine the frequency of that tuning fork, which is unknown to us. Again, resonance can be used for the tuning of the radio receivers. In radio receivers, the channels can be tuned by the means of resonance. For that purpose, it can be used. For tuning the musical instruments, they can be tuned by means of resonance. Finally, we are going to find out some of the disadvantages of resonance. It means that resonance is not always useful to us. There are some disadvantages of this resonance. Now see that the one of the familiar example or day-to-day example is that whenever we are sitting in a concert hall or in an auditorium, and if the students or the peoples, they have to clap for the lecturer or the person who is going to deliver lecture in that auditorium. Generally, what happens in school days, the clapping is in rhythmic. That is, the teacher said that just we have to clap like that. 1, 2, 3, clap, clap, clap. 1, 2, 3, clap, 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 which makes the resonance sound. It means that the number of students are going to vibrate or produce the vibrations which is having the same frequency, and the effect is that therefore as the resonance occur and the intensity of sound is going to increase, but this frequency is going to match with the vibrations of that windows. Glass windows are there if possible, or the ceiling is there, and these vibrations of clapping, they are producing the frequency, and this frequency is going to match with the frequency of that window, glasses or the ceiling. Then again, due to resonance, there is a chance of falling down that ceiling. Ceiling may fall on the heads of the student, or there may be the breaking of glasses because of resonance. This is the one of the disadvantage of that resonance. Again, one of the most familiar example is that soldiers, whenever the soldier troops, they are traveling from one point to another point. Generally, when they are doing the march from one part to another part, or they are doing parade, then they have said that they have to do the exact similar or copy of one to another, that is dyne by or 1 to 1, 1 to 1, like that. It means that all the soldiers, they are raising their right hand simultaneously, and at that time the left foot is out, and therefore we are going to see the exact and beautiful scene of that parade. And they have to strike their foots on the ground and very hard. The noise must be produced. When these troops they are traveling on the bridge, and if they are doing that kadam tal, so what happens? Number of soldiers they are present at there, they are hitting their foots on the bridge surface. There may be the vibrations, and these vibrations are exactly to the vibrations of the bridge and the natural frequency of the bridge. Therefore, there may be the possibility of these soldiers they are doing their rhythmic parade exactly equal to that of natural frequency of vibration of bridge, and therefore a resonance occurs. Therefore, there may be the chance of falling down that bridge. Bridge may be fallen, and therefore, whenever these troops, soldier troops, they are traveling on the bridges, they have ordered not to do kadam tal. Instead of that, there is a kadam tol. It means that everyone may walk in different style, not to copy each other or the exact similar type. Again, one of the example for that resonance. Again, it is a disadvantage. What happens that whenever the aeroplane is moving very fast in the air, and simultaneously what happens due to its a fast speed, the windows and the doors they are going to vibrate with larger amplitudes. As this vibration and the frequency it is going to match with the natural frequency or the own frequency of that windows or the glasses, there may be the possibility, there may be the chances of breaking down the windows and so on. It means that there may be the possibility of accident at the higher speeds. Similarly, this example can be applicable to any bus or the car. If the car is moving very fast, then it is going to vibrate. But the vibrations which are produced, these vibrations they are exactly similar to that of the vibrations of natural frequency of doors, windows, and there may be the possibility of the body or the doors or the windows they are going to vibrate with the larger amplitudes, and therefore there may be the chance of accident. These are some of the disadvantages of the resonance. But still, resonance it is the one of the beautiful phenomenon which can produce a beautiful sound. It means that bodies they are going to vibrate with larger magnitudes, larger amplitudes, and producing the sounds of larger intensities. Finally, the last point is that, and one must know that, what is that? It means that the last point is musical instrument. The number of musical instruments they are present, and these instruments are of a different type and they are producing different musical sounds because they are going to vibrate with different frequencies. The frequency of vibration is different in each case, and therefore there are the types which are used for that musical instruments. These are the firstly the stringed instrument, then the wind instrument, then percussion instrument, and the solid instruments. Firstly, we have to know that the stringed instrument. Again, generally we know that stringed instruments are sitar, veena, guitar, in which number of strings are present, and the one who is going to vibrate that veena, sitar, and the guitar. It can be seen that if the wires or the strings they are plucked, they are producing different types of sounds, and it depends upon the type of that instrument. Again, see that sitar, veena and guitar, these contains the strings, but each musical instrument is going to produce different kind of sound. Different sounds are produced from these types of instrument. Again, in case of wind instruments are like flute, bugle, bassoon. These are the saxophone. These are the flute which are based on wind. It means that by keeping the ends or the holes open or the closed, there must be the production of sound. One of the example is that mouth organ. In mouth organ also we are going to use the wind. The flow of wind produces different kinds of sound. And one of the type of resonance and the wind instrument is that we know that in summer days, in case of bamboos have the small pores, and when wind flows through that, similar can be happen to that of the pipes or the iron pipes which are in bigger buildings. It can be seen that whenever the air it passes through that pipe, it produces different sound. A sound can be heard. And in case of bamboo, what happens? There is a hole, and whenever the air passes through that bamboo, and if it is going to, that air column is going to vibrate with its natural frequency, the bamboo produces the different types of sound. One of the example of a musical instrument is that percussion instruments. Percussion instruments means that which is having stretched membrane. The musical instrument which are having stretched membrane. General example is that the drum or the tabla or the mridang. These are the types of stretched membrane in which one could find the music by hitting the stretched membrane. On hitting that stretched membrane, we can produce different types of sound on that. And finally, there is a solid instrument in which we are going to produce the different musical sounds. Therefore, these are the 4 types of musical instrument. Finally, we are concluding this chapter at this point. What we have studied. Firstly, remember that we have started with the point where how the stationary waves they are formed, how the standing wave pattern, it is also called as standing wave pattern, how the standing wave pattern is formed. This standing wave pattern contains, in which we are going to see that what happens. There is the production of nodes and antinodes. Nodes, these are the nodes. Nodes are the points where the displacement of particles of medium is very less or 0, and nodes are at this point. Antinodes are the points of medium which are at larger distance. Antinodes. Standing wave can be produced in both cases. That is, in case of longitudinal wave also produces stationary wave. Transverse wave can also produce this stationary wave. In both cases, this is going to happen.